Alright, so our universe is four-dimensional. 3 dimensions are for space and 1 is for time. Now let's mix them together. We're getting a nice dough called space-time. This dough has one amazing feature. Even though you can't use it to bake a pie, you can bend and tear it. Now forget about our culinary analogy. We're going to space. Waves traveling through space-time can travel at speeds much greater than the speed of light. Now, when it comes to propulsion, or simply put, moving forward, traveling through space by ejecting hot gas from the back of your spacecraft is not the most efficient approach. But a much more elegant way is to manipulate the fabric of space-time around your ship. That's how we get to the topic of the Alcubierre warp drive. So far, it's just a hypothetical concept, but who knows? Maybe in 10 or 20 decades, we'll use this device to visit our relatives who have moved to the other side of the Milky Way. Anyway, the warp drive theoretically contracts the space-time in front of a spacecraft, simultaneously expanding the space-time behind it. It allows the ship to move from one point to another at an insanely fast speed. While the spacecraft would be distorting space-time, someone outside the ship's warp bubble would observe it moving faster than the speed of light. At the same time, if you were that lucky traveler inside the ship, you'd feel no acceleration whatsoever. If we could make such a superluminal warp drive a reality, superluminal, which is a fancy word to describe something faster than the speed of light, it would change our lives for good. It would enable us to travel all over our solar system and perhaps help us reach neighboring star systems as well. For example, we could get to Alpha Centauri, the closest to a star system located a bit more than 4 light-years away, within days or weeks instead of thousands of years. Unfortunately, I gotta quench your enthusiasm, my friend. The warp drive has a huge problem. The force behind its operation, which is called negative energy, involves pretty exotic particles. Even worse, they're completely hypothetical, and as far as we know, don't exist in our universe. Scientists have only managed to describe them in mathematical terms. These exotic particles behave in unexpected ways. For example, they have negative mass. Boy, I wish I could pull such a trick after a big family dinner. And they work in opposition to gravity. But wait, there's still some hope left. A new discovery might solve this seemingly unmovable roadblock. Researchers from New York City have envisioned a positive energy system that does not mess with the known laws of physics. The authors of the study claim that it's a game changer and could be the first chapter in the manual for interstellar travel. You see, this positive energy makes all the difference. Now let's say you're an astronaut on a spacewalk and you decide to play tennis out there. So you push the ball away from you. But instead of floating away, the ball pushes back. And this confrontation can continue to the point that it might take your hand off if you apply enough force. Now that's a quality of the negative energy the warp drive needs. But as you can see, there's no way to harness this energy, and it sounds rather dangerous. That's why we should probably turn to good old positive energy for the construction of the warp bubble. This bubble is a spherical structure surrounding a spacecraft using a shell of regular, albeit super dense, matter. The bubble propels the spacecraft forward using the powerful gravity of the shell. But the passengers inside the ship don't feel any acceleration. An elevator ride is apparently more eventful than hurtling through space in such a bubble. All because of the immense density of the shell and the pressure it would exert on the interior if controlled properly. And since nothing can travel faster than the speed of light, according to the theory of general relativity, the bubble is designed in a way that those inside could experience normal time. At the same time, the bubble compresses the space-time in front of it and expands it behind the ship, just like that warp drive that uses negative energy. It allows it to ferry itself and the craft unbelievably fast. The walls of the bubble produce the necessary momentum, just like the momentum of balls rolling. If you decided to take up the task of controlling a warp bubble, it would require a great deal of coordination. Such bubbles need enormous amounts of matter and energy to keep passengers safe and maintain the correct passage of time. Plus, communication between people inside and outside the bubble would become super distorted during the passage through the curvatures of warp space. Now, of course, there are still tons of problems researchers need to deal with before finally building a working warp drive. But some of them claim that the model should eventually get close to the speed of light. But even if it remains below the speed of light, it'll still be a great improvement compared to our today's technologies. Hey, see for yourself. Traveling at even half the speed of light to Alpha Centauri would take 9 years. In contrast, Voyager 1, which is currently traveling at 38,000 miles per hour, would need around 75,000 years to reach our neighboring star system. There are some more things to consider. As you approach the speed of light, things get really weird. For example, the faster an object moves, the greater its mass becomes. And this mass can increase infinitely, so that the object will need an infinite amount of energy to maintain its speed. Another issue, current models allow a stable warp bubble only for a constant speed. But then, how are you supposed to accelerate at the beginning of your journey? And what should you do when you eventually need to slow down and stop? Experts claim that the process of the creation of the warp drive is like trying to figure out the concept of the automobile for the first time. We can compare the stage at which the warp drive technology is with the car technology at the end of the 19th century. At that time, automobile travel was possible, but it looked like a tricky process not everyone could deal with. Now, the whole warp drive idea is to stretch and squeeze space to zip around the universe. Well, there's a theory that's even wilder. What if, instead of bending space-time, we just ripped it? Think about it like this. When you bend space-time, you still have to deal with all the stretching and compressing. It's like folding a paper map. You still have to drag your finger across the folds. But try ripping the paper in half and slapping the two ends together. Bam! You're already at your destination. So, how can we rip space-time? We might not need to. Black holes may already be doing it. At the center of a black hole, gravity goes nuts. Everything compresses into an infinitely small point, and time itself stops. This point, called a singularity, might be that very rip in space-time. And if you could ride your spaceship into a large enough black hole, gravity might be smooth enough for you to survive the journey. Maybe. And then, some scientists think you might pop out the other side of the universe through a white hole. Okay. Now, another type of rip is called a wormhole. Unlike a black hole, wormholes have both an entrance and an exit. They're like a cosmic tunnel shortcut. If we could figure out how to find them, open them, and keep them from closing again, we could get the key to intergalactic travel. And now, get ready for a twist. Quantum tunneling. Now, let's say you're playing a video game, and your character can magically walk through walls. It's kind of what particles do in quantum tunneling. Particles can tunnel through barriers, even if they don't have enough energy to go over them, thanks to their wavy quantum nature. But what if particles could quantum tunnel through connected wormholes? Instead of just sneaking through a wall, they'd be taking cosmic shortcuts through space-time, zipping from one part of the universe to another instantly. In theory, this could open up totally new possibilities for how we understand the universe and travel across it. Ooh, you're on a beautiful planet with unusual nature. Around you are ordinary people walking on this exotic planet. And now, get this, it's our new home. Humanity decided it was time to leave the Earth, and now we live very far away in another galaxy. But what happened to our home planet? Well, our solar system itself had an expiration date. It's been 7.5 billion years since 2020, and the Sun began to expand, absorbing planet after planet – Mercury, Venus, Earth. But the living conditions on Earth were unsuitable for us long before that. Let's go back there. In 4.5 billion years, our entire Milky Way galaxy will experience an incredible incident. The Andromeda Galaxy will hit us at great speed. As a result of the collision, some stars will be thrown into distant space, while others will form new solar systems. But most likely, all life in the new Milkomedia or Milkdromeda galaxy will cease to exist. That's why people decided to pack up their things, get into new generation spacecrafts, and go to distant space in search of a new home. There can be an infinite number of planets in the universe on which humans can theoretically live. One of the main ingredients, the planet must orbit the star in its habitable zone. This means the temperature must allow the water to be liquid. We find similar star systems almost every year and have recently found the nearest one. It's Proxima Centauri. There are at least 2 planets around this red dwarf on which we can build our new home. But the problem is that this system is as far as 4.2 light-years away. So we had to open our garage and choose a vehicle that could take us so far. Saturn V is a rocket that used to take humans to the moon. It could reach the speed 30 times faster than the speed of sound. Today, we have more advanced technologies, like the SpaceX Falcon Heavy rocket. However, its speed is still about the same. It would take such a rocket about 113,000 years to overcome the distance to the closest star. So, you walk through the garage further and see the fastest human-made space object ever, the Parker Solar Probe. Its speed is a little less than 500,000 miles per hour, but it uses the gravity of the sun to accelerate. Let's assume we can build a rocket that can reach this speed. Now, we sit behind a star map, do calculations, draw diagrams, and 6,600 years. And now, let's look at the photon. These are the tiniest particles that travel at the speed of light. And an obvious thought comes to your mind. How do you build a ship that can travel as fast as a photon? Well, until recently, travel at this speed was considered impossible. Fundamental laws of physics say that no object that has a mass can accelerate this much. Energy is required to accelerate mass, and to reach the speed of light, which is about 186,000 miles per second, we need an infinite amount of energy. But it's still too slow. Raise your eyes and look at the sun. It's so close to us, but the light from it reaches our planet in 8 minutes, about the time it takes to go through the drive-thru and get your burger. And the journey to the nearest star will take 4.2 years. You can graduate from college during such a period. But we may have found a way to cheat the laws of physics and travel faster than light. Warp drive. It's a technology that manipulates space and time to break the laws of motion. In science fiction, it's a kind of field that envelops a spacecraft like a bubble or a shell and allows it to significantly exceed the speed of light. And we already have a similar technology, sort of. It's the Alcubierre warp drive. Since it's impossible to move at the speed of light in normal space-time, the ship must move by compressing the space in front of it and expanding it behind it. So not only the ship itself moves, but so does the space-time inside this bubble. In fact, this will allow the spacecraft to move at any speed, even 10 times faster than the speed of light. But to warp space-time, the ship must be simply humongous in size. It will need the quantity of energy comparable to the amount of mass energy of the whole planet of Jupiter. But at recent symposiums, scientists began to say that there is hope. In 2069, NASA plans to launch an interstellar mission to explore inhabitable planets outside our solar system. We do not yet know the details of this mission. It doesn't even have a name yet, but it will be dedicated to the 100th anniversary of the Apollo mission, the first man landing on the moon's surface. Here, near Pasadena, California, a small group of scientists from NASA's Jet Propulsion Lab are trying their best to make it happen, and their latest calculations have made everyone shout Eureka! It turns out the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round as it was thought before. It's more like donut-shaped. This will greatly simplify the design and construction. And the best part, to test this technology, a spacecraft the size of Voyager 1 probe will suffice. Researchers are now aiming to reach at least 10% of the speed of light and launch the probe to Alpha Centauri. In this case, to overcome the distance of 4.4 light-years, the probe will need about 44 years. For comparison, the Voyager 1 mission was launched on September 5, 1977. In 43 years, it's traveled about 14 billion miles and is the most remote human-made object. It's also the loneliest one in the universe. It has long since left the boundaries of our solar system and is moving further into outer space. But rest assured, scientists have a couple more ideas in their secret laboratories. There are rumors now that they know how to reach the speed of light. The Space Association is considering launching small drones powered by lasers. Nuclear force, as well as collisions of matter and antimatter, can give enough energy to accelerate an object to the speed of light too. But their colleagues in a nearby laboratory are working hard to implement another technology – ion propulsion. It uses gas particles accelerated by the electric field. Simply put, your regular rocket is a daredevil on the road. He pulls the throttle to the max and burns an incredible amount of fuel to accelerate to the speed he needs. But ion propulsion is a careful old lady driving. She slowly presses the gas pedal and accelerates. On the scale of space, the old lady will have more efficiency and will be able to drive much further than the daring young man. Something we'll keep an eye on. Still, an unknown number of years will pass until there's a way to implement warp drive or ion propulsion. We want to make humankind interstellar, but first, we need to keep it alive at least. Now we're actively developing technologies to send the first manned mission to Mars. Colonization of Mars will be the first stage to make our species interstellar. It'll be a kind of rehearsal before colonizing distant planets. We must understand that although the conditions on the exoplanets may be close to earthly ones, we will still have to terraform them. We must test our technology on Mars to warm it up to the normal Earth temperature. We also need to increase atmospheric pressure so that water could exist in a liquid state, and create an ozone layer that will protect us from solar radiation. After that, we'll be able to breathe freely on the surface of Mars without spacesuits. We need to master all these technologies before we can create a real warp drive. Centuries ago, people sailed the oceans and perfected their ships to fully explore our planet. Now, we will be the generation to build new ships and go on long journeys outside the Earth. Warp drive will open up incredible horizons for us. Take a look at our galaxy. There are countless stars. Around each of them may be planets, and on some of them, there may be life. Warp drive will allow us to get in contact with this life and explore our galaxy much faster. And this future is already close. Soon, we'll have the chance to join the pioneers, put on beautiful suits, and travel the expanses of space in search of adventure. For decades now, people have been dreaming of exploring space. And since the year 2000, there has indeed been a continuous presence of people in space. And recently, a new record has been set. Just a couple of weeks ago, there were 17 people from 5 different countries in Earth's orbit at the same time. The previous record was set in September 2021 during the privately funded Inspiration 4 mission. At that time, the number of people in orbit reached 14. So let's see. Just recently, 3 more people have arrived at China's Tiangong space station. There were 3 more astronauts aboard the same station, but they've been there since November 2022 and are supposed to return back to Earth in June. Then there are 7 people on board the International Space Station, and 4 more departed the ISS aboard SpaceX's Crew Dragon named Freedom. They successfully returned to Earth on the 30th of May 2023, leaving 13 people in orbit. Interestingly, the current record also includes the 600th person to get into Earth's orbit. Specialist Rayana Barnai from AX-2 mission became a space traveler number 600, as well as the first Saudi woman in space. But I've got something even more exciting to tell you. Oh my! The record for most people in space, and just not in Earth's orbit, was reset not so long ago too. But it lasted for a mere 5 minutes or so. But during this short period of time, there were 20 people off the planet. This record was set when 6 members of the Virgin Galactic Unity 25 Spaceship Two crew happened to be in space at the same time as 3 Chinese taikonauts living and working aboard Tiangong and 11 astronauts on board the International Space Station. Now that's getting crowded. Well, the International Space Station has always hosted the majority of space travelers from Earth. But I bet there are some cool facts about this marvel of technological development you haven't heard yet. The ISS is the third brightest object in the night sky, and the coolest thing? You can sign up for a special service and you'll get a text every time the ISS travels over your location and is visible with the unaided eye. I've seen it dozens of times myself, and it's very, very cool. Normally, you can see it between dusk and dawn, but be ready because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view from their special bay window. Now to the nitty-gritty. On the ISS, you wouldn't have to deal with lots of disgusting smells. There is a specially trained person who smells everything astronauts take with them in space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs up to $10,000. That's why it's easier to throw your clothes away when they get dirty than to waste water washing them. Now, while sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you get oxygen deprived, and that's not good. Now, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means itsy-bitsy gravity. Earth's gravity on the space station is not only around 10 to 12% weaker than the gravity on the planet's surface, but astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. But our space exploration plans are much more ambitious than just orbiting our planet on board the ISS. We're planning to send a mission to the Moon and build a colony on Mars. Some experts claim that in the next 25 years, around 20,000 people are likely to leave Earth. But how many people would it take to colonize an entire star system? In 2002, anthropologist John Moore from the University of Florida stated that a spaceship with 150 passengers could leave Earth and set off on a several thousand years journey to another star system. And upon arrival, the descendants of the original crew could build settlements in a new world. That seems like a lot of work to me. Let's continue. The nearest star system, Proxima Centauri, is 4.2 light-years away from our home planet. Talking about space, it's just next door. But for us, it's so far that we would need to build a generational spaceship to get us there. But the question is how many people you'd need to send on such a mission to have enough genetic diversity. A new study disagrees with John Moore, claiming it must be way more than 150 people. According to a scientist from Portland State University, a spaceship traveling to such a distant world would have to carry at least 10,000 people. This number might secure the success of the mission. 40,000 people would be even better. Who knows what could happen to the travelers during such a challenging and unprecedented journey? At the moment, NASA isn't ready to send humans even to Mars, let alone a distant solar system. But a few private organizations are working on this project. They hope to make interstellar trips possible in the next century. They count on a huge increase in propulsion speed, which could potentially reduce the travel time between stars to a mere few hundred years. Researchers have built several simulations to figure out how many various scenarios could play out during such an interstellar mission. And they have come to the conclusion that the success of this mission would greatly depend on the size of the starting population. Genetic diversity would keep the travelers healthy. The larger the population is, the more diversity it has. And 150 people is definitely not enough to maintain genetic variations. Even a population of 500 people wouldn't be sufficient enough. At the same time, if we sent to another solar system 40,000 people, we'd be able to maintain 100% of the variation. Even 10,000 travelers would make the scenario relatively stable, which means that any number between 10 and 40,000 people would be a pretty safe bet. But of course, we wouldn't be able to send so many people in space in just one spaceship. We'd have to build many and spread people among them. These ships could be modular, able to dock together for trade and some social gatherings, for the genetic variety, I'm guessing. But they would travel separately, so that if some disaster struck one of them, the rest would remain unharmed. But to make interstellar travel possible, researchers and engineers will have to overcome loads of obstacles. We still need to increase propulsion speed, deal with the negative health effects of living in space, and invent self-sustaining systems providing air, water, and food. Or we could just decide to fix our own planet and stay home.
You're flying through space, dodging stars and black holes. Your speed is so great that you can get from one galaxy to another in just a few minutes. Sound far-fetched? Well, all this can become a reality because NASA has already tested the technology that might allow us to travel faster than the speed of light. Let's look at the space fleet people have now. To fly into space, we use conventional rockets carrying tons of fuel and oxygen. These two substances get mixed and ignited. Fire bursts out of the rockets. The exhaust gases move downward, and the rockets move upward, as if pushing off of them. That's how jet propulsion works. This way, we can make the rocket move at almost 5 miles per second. At that speed, you could cross the United States from coast to coast in a mere 8.5 minutes. But if we talk about space, that's very slow. A trip to a neighboring planet, like Mars, takes about 7 months. And a trip to the edge of the solar system would take about 35 years. That's how long it took the Voyager space probe, launched in 1977, to get there. But we want to travel between stars and galaxies, and the nearest star, Alpha Centauri, is 4.2 light-years away from our home. That would take about 73,000 years to get there. That's longer than intelligent human civilization has even existed. And if you wanted to travel across the whole Milky Way galaxy, which is 100,000 light-years wide, it would take you about 1.7 trillion years. By comparison, the entire universe is 14 billion years old. People just travel too slowly. But even at the speed of light, it would still take 4.2 years to travel to the nearest star. And you'd spend 2.5 million years to get to the nearby Andromeda galaxy. But we can't accelerate like this. That's because the laws of physics say that an object with mass can't travel at the speed of light. A photon of light has an infinitely small weight. But if you want to accelerate even a tiny grain of sand to that speed, you'd need an infinite amount of energy. Maybe even more than the entire universe has. But scientists might have found a way around the laws of physics. To create thrust, you need to push off of something. Ships need water. Planes push off of the air. Rockets use the fuel they burn. But this thing, the M drive, works in a different way. A powerful magnetron, like the one in your microwave, sends waves into this cone. It's a resonator. It makes the waves inside bounce off of one of the walls and hit the others. As a result, we have a weak force at the narrow end of the cone and a strong force at the wide end. And if we analyze this powerful force, we'll see that it is directed toward the wide end of the cone. So, the thrust will be in the opposite direction. Now let's make this model much, much larger and put the M drive on a spaceship. The narrow end of the cone faces up. The wide end is turned downward. The magnetron starts to work. The resonator creates thrust and the rocket takes off. It makes no noise and doesn't emit any harmful gases at all. This mechanism can accelerate the rocket much faster than we do with tons of fuel. In theory, we could even reach the speed of light. Sounds great, but in reality, it isn't. Although the inventor of this device tried to prove the M drive works, no independent experiment around the world has shown positive results. NASA sponsored the construction of such a machine in a laboratory, but it didn't create any thrust during the research. Another option that would allow us to travel much faster than the speed of light is the Alcubierre bubble. A Mexican scientist has figured out a way to use the general theory of relativity without breaking the laws of physics. Let's say we have a spaceship on a space-time blanket, and it needs to make a trip to the other end of the blanket. Instead of just moving from point A to point B hundreds of thousands of light years away, the ship starts pulling the blanket toward itself. As the spacecraft folds the blanket, point B moves toward it. Now the ship needs to travel a much shorter distance to point B. It makes a quick trip and then straightens the time-space blanket back to normal. Voila! So such a spaceship doesn't need powerful engines that will burn tons of fuel and oxygen. It would move in a kind of bubble. But the hardest part is creating such a bubble. To do this, we would need an amount of energy roughly equal to the mass energy of all of Jupiter. That's more than we can produce on Earth. And still, scientists are planning to test this technology on a small space probe the size of Voyager. But this experiment might last for decades, or even centuries. Now scientists are trying to reach at least 20% of the speed of light using a laser. And they're planning to get to Proxima Centauri in about 30 years. It's likely to happen like this. A mothership will launch from Earth. It'll carry thousands of fingernail-sized space probes. After reaching orbit, the mothership will launch the probes into space. Each probe will then deploy a sail, a thin, reflective piece of material the size of a parking lot. Then people will focus a powerful laser beam from Earth directly onto the probe's sails. This will give them an acceleration 1,000 times as strong as the acceleration of free fall on Earth. One by one, the probes will launch and head for their destination. We won't even have to maintain that laser beam all the time. If you turn off the engines of a regular ship on the water, it'll start to lose speed due to friction with the water. But space is an almost perfect vacuum. There's literally nothing there. So there's no friction. All we have to do is accelerate the probes to the needed speed. At 20% of the speed of light, these probes could reach the Sun in just 40 minutes. But instead, they will head for the star Proxima Centauri. After about 30 years of travel, 4 more years will pass before we get a signal from the probes. There are several exoplanets in this system, and some scientists hope to find at least traces of life there. But this sail technology can be used in space even without a powerful laser. We can use the Sun. If we create a sail the size of a soccer field and unfold it in space, it'll start catching the Sun's rays. And since the surface of the sail is reflective, the rays will bounce off the sail. This will create thrust and propel the spacecraft. One disadvantage of this technology is that we can only use it inside the solar system. In cold interstellar space, the sail won't be able to catch the Sun's rays or solar wind. Another candidate for faster-than-light travel is an ion thruster. Like a conventional rocket, a spacecraft with ion thrusters would be propelled by gas ejected outward. Only, in this case, the gas would be ejected not because of fuel combustion, but because of an electric field. We'd need to create a powerful electric field inside the engine. Particles of gas passing through this electric field would get accelerated and ejected outside. This would create thrust. And although the acceleration in such an engine would be many times weaker than in a conventional rocket, the ion engine would be able to reach higher speeds. NASA was planning to build an ion-powered spacecraft to fly to Jupiter. Ion engines consume a lot of energy, so the ship was to be equipped with a nuclear reactor and lots of solar panels. 8 large engines were supposed to accelerate the spacecraft to about 56 miles per second. At this speed, the trip from New York to London would take 1 minute. So far, this technology has been actively tested on different space probes, but it can't provide a solution to how to travel faster than the speed of light. Perhaps people will still be able to travel between galaxies in conventional rockets, but they'll need to use some sort of shortcuts called wormholes. So, back to our space-time blanket. Point A lies at one end, and point B is at the other. Instead of traveling across the entire blanket for millions of years, you can simply fold it. Then point B will be right above point A, and you can quickly get there through a short tunnel between them. Such tunnels are called wormholes. Some scientists believe that wormholes can be inside black holes, but there are 2 problems here. The nearest black hole is 1,500 light-years away, so a trip there would take eons. The second problem is the hole's gravity. Black holes have the strongest gravitational pull of any object in the universe. Their gravity can crush any spacecraft. That's because the gravitational force increases with every inch you move closer to the black hole's center, and the force affecting the nose of the spaceship will be much stronger than the force that affects the tail. The spaceship will stretch out like spaghetti and get torn apart. But there's a theory claiming that a spacecraft or even a person can survive falling into a black hole, but only if the black hole is supermassive, like the ones that lie in the centers of galaxies. They can be millions and billions of times heavier than the sun. But even though they're heavier, they're also bigger in size. This means gravity probably doesn't increase so fast there. You or your spacecraft might not turn into spaghetti, and might even get to see what's at the heart of the black hole.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun, and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has two designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If two spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert.
Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank. Because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So, we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome. And when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the endpoint, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here, we don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build a lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper. But NASA's main reason why they chose not to go along with this project is that right now there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining, too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth.
Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is… no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms, of course. Only the Alpha Centauri trio is closer to us. Bernard star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Bernard star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Bernard star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Bernard star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Bernard star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super-sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Barnard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory, rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real Smartie. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
Space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's going to take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk? You're shopping for a bike and the friendly salesperson offers you to test the prototype for a new model using new technology straight out of space. It turns out you're already using some interstellar inventions on a daily basis. Regular inflatable rubber tires can't do so well on the perilous rocky and sandy terrains of the Moon or Mars. Curiosity Mars rover got some damage to its treads just 16 months into its mission. That's why airless tires relying on a mix of nickel and titanium were invented for NASA rovers. The material is flexible thanks to its tight molecular structure and can return to its original shape every time it deforms. The same airless technology should work great with bike tires down on Earth. The tires are tube-shaped and squash down whenever you roll over a bump. They will develop perfect shaped memory over time. They're supposed to work best on gravel, trail, and mountain bikes. When it wears off eventually, the company plans to retread the tires to get the bike back on the trail and to make it last for years. The previous airless tire models were made of patented foam, supposed to last for up to 5,000 miles. They didn't take off because they made the bike too heavy. The new model is supposed to solve that problem and give the world innovative, lightweight, and durable tires. The same tech can be used in an all-terrain car and truck tires, high-performance sports, commercial aircraft, and even search and rescue missions. You gotta thank NASA for that comfy memory foam mattress you're using every night. Back in 1966, the original idea behind memory foam was to customize seats for astronauts to somehow ease the effects of G-force on takeoff and landing. It would be too impractical to create a custom seat for every flight, so memory foam became a perfect solution. It easily adjusted to an astronaut's body shape and went back into a rest state when not in use. Memory foam became available to the general public in the early 1980s and is now used in products from mattresses and pillows to amusement park rides, horseback saddles, and football helmet liners. Lenses used to be made of ground and polished glass. In 1972, a new regulation made their manufacturers turn to plastic to make them shatter-resistant. The new lenses were too prone to scratching, so NASA's invention of a diamond hard coating for astronaut helmets and other plastic aerospace equipment came in handy. The new tech was further developed and used for the production of scratch-resistant plastics. It's now used in most sunglasses, prescription lenses, and safety lenses in the US and around the world. The next time you clean your car's interior with a dustbuster, remember, you gotta thank NASA and their Apollo space mission for it. They wanted to come up with some portable self-contained drill to extract samples from below the moon's surface. They developed a computer program to produce optimal motor power and minimize power consumption. This program was later adapted and used to create a whole series of useful battery-powered home devices. The most famous of them was the cordless miniature vacuum cleaner under the original name of Dustbuster. In case you didn't trust the name, space blankets are indeed a product of NASA research. They're lightweight, usually gold or silver in color, and capable of reflecting up to 97% of radiated heat. That's just what you need to reduce heat loss from the body and stay warm and comfy in space. The material was originally designed for the exterior surfaces of spacecraft. Now you can see marathon runners at the end of the race wrapping themselves in those blankets to regulate body temperature. It normally drops right after you stop running. Another NASA invention is insulation called Radiant Barrier, made from aluminized polyester. It was designed to survive in wildly cold space temperatures and is now used in most home insulation. Freeze-drying tech for food was not created but greatly improved by NASA to pack more snacks on long Apollo missions. The idea is to cook food, then freeze it under low pressure, and then slowly heat it in a vacuum chamber to remove ice crystals. To bring it back to normal, you just have to add water. Thanks to this tech, food maintains 98% of its nutritional value with only 20% of its original weight. It's a great help for backpackers, disaster relief programs, and anyone who needs to pack light and still get proper nutrition. The infrared thermometer that lets us check temperature from a distance was developed with the support of NASA as well. It measures thermal radiation emitted by your eardrum a lot like they measure the temperature of stars and planets. Each device has a lens that focuses light from the object onto a special detector that converts radiation into an electrical signal and then into temperature you can see on a display. It's used for many purposes, from monitoring hotspot temperatures in mechanical and electrical systems to checking the temperature of visitors in public spaces. In the early 1960s, headsets for airline pilots used to be really bulky. They often used handheld mics to communicate. NASA needed a more reliable and lightweight technology for their missions to ensure communication, especially in case of emergencies. They got in touch with the pilots. Just 11 days later, the team came up with a microphone headset unit that could be used by astronauts to communicate with one another and with Earth. The headset was later improved and used for Mercury and Apollo missions. The world was able to hear Neil Armstrong's most famous phrase as he landed on the moon thanks to that wireless headset. You gotta thank NASA for the improved version you use today. The idea behind LED technology dates back to the late 1980s. Back then, NASA was looking for a way to grow plants in space. They tested the tech using wheat and just red LEDs. It wasn't a success at first, but they solved the problem using blue fluorescent lights. The technology was developed and used in many medical devices and everyday items like electricity-saving LED bulbs. These days, they're way more efficient than their ancestors. Every time you take a selfie with your friends, you're using the tech that originated from the one for interplanetary missions cameras. NASA scientist Dr. Eric Fossum developed special active pixel sensors to make those cameras as small as possible and maintain the high image quality. This tech has become the leading one in the digital imaging industry. It made it possible to add miniature cameras to smartphones and other gadgets. Astronauts spend long periods of time in weightlessness and need a way to exercise regularly to stay in good physical shape. NASA took care of it and designed the anti-gravity treadmill, stimulating added weight and mimicking gravity. On Earth, the same method helps to lighten the load on your legs as you're working out. This tech is used by professional athletes and people trying to get back on their feet. You gotta thank NASA for your favorite pair of athletic shoes. They came up with a rubber molding process to absorb shock in space helmets and suits. The same idea was applied to athletic footwear and opened up new possibilities for professional sportsmen. And they're just way comfier for everyday use. The computer mouse was invented as part of a huge project aimed at augmenting human intellect. The inventors came to NASA in 1966 to test the mouse. It turned out the mouse was better and faster at manipulating objects on the screen than other gadgets like the light pen. The first mouse came with a cord in the front, but they moved it to the back to get it out of the way. The first patent for something that looked and worked like a joystick was filed in 1923. But it was NASA who made it something widely used. Astronauts in bulky suits needed a steering mechanism that would work with one gloved hand. The joystick was the best choice that spread to training simulators for astronauts and home computers. Invisible braces are a product of Ceradyne and NASA's Advanced Ceramics Research Program. You probably use them to straighten your teeth, but the original idea behind them was to find some material to use in structures protecting radar equipment. It had to be as transparent as possible for radar waves to pass through easily. It was doing well at its job, and in 1986, they got the idea to use this transparent and strong material in the dental industry.
That's one small step for man, one giant leap for mankind. Something Neil Armstrong, the first human that set foot on the surface of the moon, said. He was there with Buzz Aldrin, spending 2.5 hours on the lunar surface. Preparation for this project took a couple of years, and all the equipment the astronauts carried weighed over 170 pounds. It wasn't easy to land on the moon. There were lots of attempts in history that ended in failure. For example, astronauts in one of the Apollo programs had enough fuel to rocket people to the lunar surface in a mere 3 days. But they wanted to save on fuel, so it took them over a month to get there. There's no GPS to tell you where exactly to land. The spacecraft travels fast, and it has to slow down in a vacuum with not enough information. But since 1969, 12 people have already walked there. The moon is the only space object humans have visited so far. The rest have only been visited by robots. But all these people were just there for a short visit. NASA announced their program to work on a permanent presence on the moon. That would help scientific research and could be a good point to learn how to do the same on other missions, like the one on Mars. Imagine being the 13th person going to the moon. Scary silence, moon dust under your feet, and nothing but an endless black sky with stars all over you. But you have no time to admire the view. There are many issues you'd need to figure out before landing. First of all, our bodies are like machines that are adapted to conditions on Earth, like gravity, atmosphere, the air we breathe, and the food we eat. Our planet is where we function optimally. Our gravity is 6 times stronger than on the moon, which is, compared to our planet, almost a vacuum. Whatever you do, It wouldn't be smart to hold your breath in such conditions. The vacuum would pull the air from your body. Oxygen still present in your body would expand together with bodily fluids. They would push against the blood vessels and organ tissues. Your body, legs and arms, they would all lose their current shape and would bloat like a balloon to twice their normal size. If you stayed like that for a longer time, you wouldn't survive. But you wouldn't explode. Your skin is pretty elastic, and it would hold your body together. Liquids that are exposed to your body would evaporate. The surface of your eyes and skin, it would all boil. Saliva would literally boil on your tongue, but the blood would still be liquid. The walls of the vessels would protect it from boiling. No atmosphere, no oxygen either. The oxygen that's already in your lungs would quickly be gone, and you'd have nothing to breathe in. If your organs stopped getting oxygen, usually delivered to different parts of your body by blood, you'd pass out because your brain would shut down. It would happen in the first 15 seconds. That's how much time your body has to use the remaining oxygen in the blood to keep the brain functioning. Stay like that for a longer time, and bye-bye. No ozone layer, no strong magnetic field. The atmosphere of the moon is similar in density to those uppermost layers of the Earth's atmosphere, where we have the International Space Station. That means your body would be exposed to all those dangerous ionizing radiations from outer space we can't feel now, because layers surrounding Earth keep us safe. On Earth, our muscles and bones are tuned to resist gravitational force. Without gravity, we'd start losing muscles, and our bones would become weaker. It's like with the blobfish, a marine creature that looks like the saddest animal on Earth. This fish lives deep down in the ocean. When down there, it looks like most other fish, just slightly scarier. But when it's out in the fresh air, it becomes flat, and its entire body looks like some weird, sad pudding, all due to differences in pressure. The moon would make you look like a blobfish because of drastic changes in atmospheric pressure. There's no pressure that would hold your body together. While on Earth, a column of air presses an approximate mass of 15 to 20 tons on the entire surface of your body. We don't notice this because this air pillar presses the body equally from all sides. There's air inside your body too. Internal pressure is the same as the atmosphere. And on the lunar surface, there's no pressure from outside to back it up. It's also really cold up there. Temperature drastically changes from 250 degrees Fahrenheit during the day to negative 208 degrees Fahrenheit when it's night. A day on the moon lasts 29 Earth days. That means you'd be spending 14 and a half days in unbearable light, and the next 14 and a half days in scary cosmic darkness. Your body could eventually freeze solid if it's nighttime, the same as in other places in space. Depending on where exactly you're at, this would happen within 12 to 26 hours. Or, if you visited the moon during just one regular afternoon, you'd be burnt to a crisp. It's better to do what Apollo 11 did and come at dawn. The lunar surface isn't so cold yet, and it didn't have enough time to become extremely warm. Even if you survived all this, there are millions of meteor strikes every year. All those small particles of rock or dust that move pretty fast, or even orbiting debris from spacecraft or satellites. A human being wouldn't be able to survive in these conditions for more than 1 minute. To make it, and stay a little bit longer on the moon, the first thing you'd have to take care of is getting protection from radiation. You'd need simulated atmospheric pressure similar to Earth's, and it has to be stable. You'd have to maintain the temperature of your environment, so your body doesn't freeze or burn out. Protection from space debris and cosmic dust, breathable oxygen. Oh yeah, you'd also need a communication system, water, food, and maybe some other things that you'd need to function normally. In 1982, NASA started using an extravehicular mobility unit, EMU, for their activities in outer space. The latest Artemis mission has spurred the development of a new generation of spacesuit. The XEMU is an amazing new generation suit that they came up with. It will probably be deployed within a couple of years. The suit has supplies of oxygen, both for breathing and for maintaining the pressure that holds your body together. One part, the liquid cooling garment of the suit, is form-fitting, which means it fits your body shape and has a system that receives cold water and then circulates it across the whole suit. That's how it maintains a temperature of around 70 degrees Fahrenheit. The water absorbs heat and then moves to the second part, the XPLSS of the suit. The Moon is our planet's only permanent natural satellite, the second densest satellite right after Jupiter's moon Io. It was formed in a collision known as the Big Whack. A huge Mars-sized space object hit our planet 4.6 billion years ago, shortly after we got the solar system and the sun. A cloud of vaporized rock was formed, made of a mix of particles from Earth and the other object. It went into orbit around our planet, cooled down, and turned into a ring of small solid bodies. They later got together, which is how the Moon was formed. The Moon has some cool things, like unusual water that moves and jumps around as its surface gets warmer and cooler throughout the day. The water is there until some of it melts, heats up, and ends in the Moon's atmosphere. The water then floats around and then gets to the area that's cool enough to go back to the surface. The Moon always shows us the same face. Its near side is marked by pretty big dark plains. There are still footsteps on the surface of the Moon because no one has been there since 1972, the year of the last Apollo. There are no geological activities there, like volcanoes and earthquakes. No rain or winds to erase them. Wouldn't you say it's time to make some new ones?
On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon.
Joseph Walker is about to have an historic flight, but he does not know of it yet. He smiles at his chase pilot, showing the OK sign, and closes the cockpit of his steel friend, the newest unpowered rocket plane, X-15. It's placed under the wing of a B-52 bomber. They take off and go up to 45,000 feet. Joseph is calm and full of joy because he has been getting ready for this moment his whole life. He trusts his steel-winged friend like no other. The bomber drops the X-15. The rockets fire up, and with a fantastic thrust, Joe flies steeply toward the edge of space. He knows his dream of making the first ever suborbital plane flight will soon come true. Joe adjusts the controls to intensify the rocket energy. In contrast to the usual blue sky plane view, the beautiful curved planet Earth view and a black horizon is a visual privilege only a few people can have. Joseph Walker's reaction shows he is experiencing zero gravity. "Welcome to space," the pilot says quietly. "We did it, guys."
The Walker surname has always automatically propelled him to action. He just had to go forward, strive for higher results, and not stop. As a teenager, he loved to run, arms outstretched at the sides. He imagined that his legs lifted off the ground suddenly, and he felt himself flying, soaring up both as a man and an airplane. When he worked as a test pilot, he used to fly over city lights at dusk. They assembled themselves into gigantic mosaics below and reminded him of faraway stars he wanted to reach. His dream of becoming an astronaut and getting the astronaut wings, which he considered a great honor, was born at that time. On his way to his dream, Joe studied a lot and got a bachelor's degree in physics. He also had extensive test experience in the early X-series aircraft and 27 flights in rocket aircraft after joining the NACA, which stands for the National Advisory Committee for Aeronautics, in Dryden in 1951. He combined the experience with sound engineering judgment. What drives a test pilot to risk his life every day? Courage, duty, devotion, passion? All of it. Joe was a talented test pilot and would not have traded jobs with anyone, but he had always aimed higher. So he became the right person for the X-15 spaceflight program when he was invited to be its chief pilot. The whole team, including the engineers and all the 12 test pilots, had to prove that they could design an airplane that would fly and survive at hypersonic speeds. Before, there was only a theory about hypersonic flight and subscale wind tunnel testing. That's why there were many questions like, will they be able to prove it? Will they manage to design an airplane that will be stable and controllable at hypersonic speeds? Could they possibly create a structure that would survive the high heating rates associated with hypersonic speeds? And, more importantly, could a pilot survive and function adequately in this high-energy environment? When the X-15 launches from the bomber's wing, it first goes into a free fall for several seconds, and only after that the rockets can be ignited. So there was a considerable risk of a rocket failure too. The team also had to design an airplane that would be controllable outside the atmosphere and could successfully re-enter it at high speed and steep entry angles. If the X-15 took the wrong angle, the plane would be destroyed. So could they prove all of this? To regularly tempt fate is a real job of any test pilot. Joseph knew the anatomy of his winged friend as much as his own because his life depended on it. The X-15 looked like a big propellant tank with a cockpit. It was 50 feet long, 20 feet wide, and 13 feet high. But the propellant tanks took up approximately 25 of those 50 feet. The X-15 weighed 15,000 pounds without propellants and 33,000 pounds loaded with them. The propellants consisted of liquid oxygen and anhydrous ammonia. To fly at the hypersound speed of Mach 6 or 4,000 miles per hour, one must have an airplane that will survive temperatures as high as 1,200 degrees Fahrenheit. That's why the X-15 was built of steel Iconal X, a tough, high-strength nickel-steel alloy. Only 3 aircraft were built. The X-15 was by far the fastest plane existing at that time. It could fly at a speed of up to 7 times the speed of sound, which is 4,520 miles per hour. Joseph Walker could fly to the edge of space and land again within 12 minutes. The plane was powered by a liquid rocket engine reaction motors XLR-99, which delivered a powerful thrust of 57,000 pounds. During Walker's first X-15 flight, he was unaware of how much power the rocket motors had, and he was slammed into the pilot's seat yelling, "Oh wow!" The enormous ejection seat weighed 270 pounds. It had 2 large stabilizing fins deployed after ejection and 2 large telescopic booms that extended for seat stabilization. The aircraft had a conventional wing, although small, with only a 22-foot span and roughly 200 square feet of area. The aircraft's tail was unusual, with 2 canted horizontal and 2 vertical surfaces. These tail surfaces resembled the feathers on an arrow. They served the same purpose, keeping the aircraft stable and pointed in the right direction. The upper and lower vertical tail surfaces were pretty large and thick compared to conventional airplanes. They were wedge-shaped in cross-section with a sharp edge in front and a broad base at the rear. This provided additional stability and prevented the aircraft from swapping ends at extremely high speeds. The airflow sensor on the airplane's nose determined the airflow direction and impact pressure. This sensor was referred to as the ball nose. It was servo-driven to align with the airflow affecting the aircraft's nose. From this, the engineers obtained the angle of attack, the side slip inclination, and the impact pressure of the air flowing over the aircraft. The ball nose was cooled with liquid nitrogen to prevent it from melting during high-speed flight. Walker sometimes liked to playfully bet with his fellow test pilots who would be the first to lift the rocket plane above the Kármán line, the internationally accepted boundary of 62 miles. On August 22, 1963, during Flight 91, Joseph Walker sets a world record of the highest altitude of 67.08 miles reached by an unpowered plane X-15. The X-15 is hoisted up to the pylon on the B-52 wing. The hoists are located in the X-15 servicing, fueling, and mating areas. All pre-flight checks are completed. Takeoff. The X-15 is the first aircraft to utilize an inertial platform and a computer. Standard barometric instruments are almost useless in the X-15. Joseph has them on the instrument panel, but he only uses them during landing because they don't work at high altitudes or outside the atmosphere. For a sizable portion of the flight, he uses inertial data for control and guidance. Launch. The X-15 drops away from the bomber and gets into a freefall for several seconds. Then the rockets start by burning within 85 seconds, producing extreme power. Joseph pulls the plane up at a steep climb-out angle to start forming a long parabola and comes out of the atmosphere. The pilot has good visibility since the windows are next to his head. One very unusual thing about the visibility out of the X-15's windows is that the pilot cannot see any part of the airplane. He cannot see the nose, he cannot see the wings. Nothing. Typically, pilots use the nose and the wings in an aircraft for attitude reference. In the X-15, all Joseph has for a reference is the window frame, which is very disorienting on the one hand. But on the bright side, such a panoramic view is just right to enjoy the splendid horizon, a boundary between Earth and space. Joseph thinks how quiet it is here, like nowhere else. Mission completed. Joseph completes a perfect parabola and re-enters the atmosphere successfully. The X-15 is like a tough old bird that pops and bangs as it accelerates above extreme speed. But it all hangs together and gets Joseph Walker back home. He is ready to start a glide, landing from space. The X-15 has some outstanding features that significantly enhance the safety of landing. It has highly effective speed brakes, which are essential in an unpowered aircraft to adjust energy and ensure a pilot gets back to the ground safely. The more effective they are, the more precise the control of the power and the more accurate the landing. It's hard to imagine, but the pilot lands the X-15 only about 11 minutes and 8 seconds after its launch, having gone through the distance of 337 miles. Joseph Walker makes history as the first civilian test pilot flying to space by a rocket plane twice. Despite all the risks of the X-15 program, The courageous test pilots pushed the very limits of their piloting skills and physical health to master groundbreaking experimental technology. The program's overall success helped develop the Space Shuttle program and paved the way for NASA to continue to the Moon decades later. Joseph Walker got a lot of awards and the cherished astronaut wings, but only many years later. The Lunar Landing Research Vehicle, used to develop piloting and operational techniques for lunar landings, was trusted to be piloted by Joseph, and the famous moon crater Walker was named in his honor. Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes used Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. Messenger really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, 1 European, the MPO, Mercury Planetary Orbiter, and 1 Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bepi Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar-wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that Messenger failed to detect. Bepi Colombo launched in October 2018, and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby! In 2025, humans will have a unique opportunity – travel to the moon. So far, only 12 people have walked on Earth's natural satellite, but a private company is offering tourists a chance to change that. If you are hog-stinky rich, you can pay $750 million to spend several days exploring the moon and watching Earth from a distance. You can even join unique scientific experiments. Now, humans also want to build their forever homes on the moon. In fact, NASA believes that North Americans may have their own share of the moon by 2040. And you don't even need to be an astronaut to buy a plot of land on the moon. Of course, billionaires are already making plans. Their first idea is to exploit natural resources. The moon is packed with stuff that is rare here on Earth, like helium-3 and many rare Earth minerals, or more precisely, rare moon minerals. But I digress. Hey, if you can get your hands on some of it, you may get even richer. First, helium-3. It's great for clean nuclear energy, but it's super rare on Earth because it escapes into space. The moon, though, has tons of it, enough to power Earth for 1,000 years. Rare earth minerals are not actually rare on Earth, but they're hard to mine because they react with oxygen. On the moon, hey, there's no oxygen, so we could easily get loads of these materials to make better tech, like electronics and batteries. Scientists aren't thrilled about this. For the first time, they have a chance to explore 4.5 billion years of space history. Because the moon's soil has stayed the same for billions of years. Studying its rocks could reveal lots of secrets about the universe's origins. But if billionaires mine the moon and destroy these rocks, all that knowledge could be lost forever. Another problem with exploring the moon is the size of it. The moon is big, but the best spots, the ones with water and sunlight, are limited. Most of the lunar surface is dangerous because of earthquakes or moonquakes, radiation, and meteorites. That means tourists, scientists, and mining companies would be elbowing each other in 3 small regions. The first region is called the Peaks of Eternal Light because there's always sunlight over there, making it a great energy source for telescopes or human colonies. The second spot is the far side of the moon. Here, radio signals from Earth are not so strong. It's not just peaceful and quiet there. It's also a great place to set up a telescope and study the universe. The third place is called the Pits of Eternal Darkness. It's where all the trolls on social media go on vacation. Nah, it's really because no sunlight reaches that area. This place is even better for scientists because they can use special astronomy tools to study the most distant parts of the universe. This is also where you can find about 1 billion tons of water. If scientists could visit the moon and study it, they would make amazing discoveries. But today, there are no international laws protecting space. No country can own the moon, but this can't stop a private mining company from calling dibs on a particularly good spot. In the past, a bunch of nations signed the Outer Space Treaty, and they agreed that space exploration was supposed to benefit all humankind. But exploring it is not cheap in the first place. Taking a single gallon of water from the moon to the Earth is extraordinarily expensive, and I bet not everyone can afford that. Human activity on the moon is also extremely dangerous because it might change its atmosphere. Now, to understand it better, let's look at the surface of the moon. This floating rock has many craters that have been forming for billions of years. When a meteorite crashes into the moon, fine dust called regolith, with particles so tiny they can cut like glass, rises into the air. This process once created the atmosphere of the Moon, and this atmosphere is quite different from the atmosphere of Earth. A big rocket landing on the Moon can launch this fine dust into the lunar sky, and the difference here is that the space objects crashing into the lunar surface are actually gentler. A rocket landing is so intense it can increase the number of atoms in the sky 100,000 times. If the number of atoms in the atmosphere grows, the air turns into a dusty plasma. This means that you'll be breathing in air as toxic as the one that poisoned miners in the olden days. Such an atmosphere could end space tourism too, because it makes electronics malfunction and machinery shut down. Well, truth be told, our own presence on the Moon is already dangerous. When scientists discovered water on the surface of the Moon, they were super excited to study it. This was their chance to understand where this water came from, and even figure out how water appeared on Earth. But when our spacecraft land on the Moon, outgassing occurs. This means that the water on the surface evaporates. This evaporated water can contaminate the water on the Moon, ruining all scientific data. Because when astronauts take a sample of the lunar water to study it, they will get the water from Earth they have brought along. Bummer, really. And it's not just the water we contaminate, it's everything. A spaceship can carry any living thing from Earth to the Moon. It can also bring extraterrestrial life forms back to Earth. This type of contamination is extremely dangerous because it can put human lives at risk. Something similar happened when Europeans were exploring unfamiliar lands they came upon in the Americas. They accidentally introduced new microbes to the natives they met. And since the immune systems of the native population were not used to those new bacteria and viruses, they got sick and worse. At the same time, Europeans also became ill with diseases their bodies didn't know about yet. And even though moon tourism is not happening yet, humans are already littering the lunar highlands like their own backyard. In 2024, an artist named Jeff Koons sent a sculpture to the Moon. The sculpture is a transparent box filled with spheres, and it got to the Moon thanks to a ride on a SpaceX Falcon 9 rocket. In each sphere, Koons engraved the name of a human he considered super important to humankind, like Aristotle, David Bowie, and Leonardo da Vinci. Thankfully, you don't have to go all the way to the Moon to see this sculpture. You can purchase an NFT of each sphere. Or not. Back in 1971, the crew members of Apollo 15 also left a couple of things on the Moon. A figure created by a Belgian artist and a commemorative plaque to honor other astronauts who couldn't be there. And it's not just art that humans dumped on the Moon. If you take a walk, you might just stumble upon 413,000 pounds of materials left behind, including a gold olive branch, a falcon feather, a silver astronaut pin, a Bible, some golf balls, a hammer, and even leftover urine collection kits. Most of this stuff was left behind by the astronauts that explored space between the 60s and 70s. So you can find moon rangers, lunar probes, and orbiters that are decades old already. Now, to be fair, bringing back unnecessary equipment costs a ton of money. And back in the 60s, their priority was the safety of the astronauts. The sad truth is that the Moon is already turning into an extraterrestrial landfill, and we don't even live there yet. But now we want to settle there, so NASA is trying to get rid of all this trash. The good news? Hey, you can be part of this process. The space agency launched a competition called the Luna Recycle Challenge, and if you want to join it, you must find ways to reduce the amount of litter produced and recycle it into materials that can be used for space exploration. To win, you need to develop a way to completely recycle the trash that is on the surface of the Moon. You will help science and win $3 million. And if you get this sum, well, you might finally afford a ticket into space. Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we capture the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now, it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first?
When you look at photos taken from spaceships or the International Space Station that show sunlit objects like Earth or the Moon, something seems wrong. Space looks too empty. No magical scenery of a nighttime sky full of stars. It would be incredibly boring to go stargazing in space, since the sky is always dark. During the daytime, the sky on our home planet is blue because of the diffusion of light. It happens when sunlight goes through the atmosphere. But if you were on the moon or somewhere else in space, there would be no atmosphere to spread this light around. That's why the sky there would always appear black. But it doesn't mean less bright out there. If you were looking out the window of the space station, you'd see just as much direct sunlight as you would gazing out of your apartment window during a cloudless day, maybe even more. When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the moon. But it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite, an orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the Sun than our planet. So, when you're looking at the Sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the Sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the Sun's rays, so only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets Mercury, Venus, Earth, and Mars don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, or they may be the remains of a moon that got destroyed by a collision with some space body, or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings. There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means that they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we know today as the Moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists call this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune and 10 times more massive than our home planet. It's likely to circle around the Sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the Moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the Sun as our planet and receives less sunlight and heat. But it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the Sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 miles per hour. Can they produce this heat? Or maybe it's because of the planet's core, or its gravitational force? There's a monster black hole hurtling through space at a speed of 5 million miles per hour. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us. Solar storms are so powerful that they could leave us in complete darkness. Back in July 2012, the strongest solar storm in over 150 years narrowly missed Earth. Coronal mass ejections, or CMEs, are large bubbles of ionized gas. They tore through our orbit back then. If they had caught our planet in the crosshairs, we would have literally been in the firing line. we'd have faced solar matter hurtling towards Earth, damaging computers and causing power outages that would have lasted for months. A surprise solar storm hit us on June 25, 2022. One photographer even managed to capture stunning bright auroras that flashed across the dawn sky in Calgary, Canada, and lasted for 5 minutes. They were caused by the storm. Vampire stars are a real thing. They're part of a binary star, and they can literally drain the life out of the other star in the system. They do it to keep burning for a longer time. It works like this. A smaller star with a lower mass steals its sibling's hydrogen fuel to increase its own mass. This vampire star then becomes hotter. Plus, its color changes to striking blue. This way, it looks much younger. How sneaky. The color of the universe is dubbed cosmic latte. The light coming from our galaxies and stars within them, as well as clouds of gas and dust in the observable universe, have a specific color. It's an ivory tint, pretty close to white. The universe is beige because there are a bit more areas that produce green, yellow, and red light than those that emit blue.
Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there'll be plenty of surprises, too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view, and the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer Joseph Louis Lagrange in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a 3rd temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turned to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. that's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over. Slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on 2 legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
Many people would like to fly into space. Zero gravity, a stunning view of Earth from one side, and the boundlessly frightening black area from the other. Yeah, it's all cool. But don't forget that this journey can turn into a nightmare. Lack of oxygen, floating in outer space and staying in a spaceship for a long time without understanding when you can return home. This last thing happened to a Russian cosmonaut. His stay in space is one of the longest in the world. 33-year-old flight engineer Sergei Krikalev spent 311 days in zero gravity on the Mir space station. But that's not the most interesting part of this story. Sergei's long journey began on May 18, 1991. That day, he boarded a transport ship and went into space to the Mir space station. On May 20th, the docking with the station was completed. There, together with another engineer, Sergei performed his space duties. They went on spacewalks several times, did repairs, took care of the station, and conducted scientific experiments. When you have company and a lot of work, living in space is not so hard. But things got worse on the day when Sergei was supposed to return home. According to the plan, the mission should have lasted for 5 months. A new astronaut was supposed to replace the old ones. The transport ship had finally docked with the station. But on October 10th, only one astronaut returned to Earth. Sergei was left alone at the Mir station. He continued to work as the sole flight engineer of the crew. The station couldn't remain empty. They had to send someone to replace Sergei. He wasn't ready for such a long stay in space. He hadn't trained for it. But there was no choice. He couldn't just leave the station. 1 month passed. They informed Sergei that he would return home soon, but something happened that no one expected. They contacted Sergei and said he couldn't return, since the country that promised to bring him home no longer existed. During this time, a big crisis began in Russia. The cosmonaut's return was impossible, since no one had the money for it. Just imagine Sergei's condition. You are hundreds of miles from home, in black outer space, completely alone, and have no idea how many days you have left to be there. The days passed slowly, weeks, then a month passed. It would have been much easier if being in space was not harmful to your health. But in conditions of zero gravity, the human body takes serious damage. First, it's a weakening of the muscles. The body doesn't receive the necessary load it needs, and the muscles are constantly in a relaxed state, leading to dystrophy. Yes, astronauts do a set of exercises every day, but this is not enough to keep the body in shape. In addition to muscles, bones begin to weaken and a person becomes weak. Even after 6 months of such a life, any astronaut needs a long time to get back into their previous shape after returning home. Also, there's a lot of radiation in space, which is dangerous for people. It comes from several sources at once. The main radiation comes from the sun. On Earth, we're protected from it, thanks to the planet's magnetic field. Almost all radiation accumulates in the upper atmosphere and doesn't reach us. This accumulation of radiation in the atmosphere is also bad for astronauts. But the worst radiation is the galactic one. It comes from distant stars and galaxies and has a powerful effect on all living things. Radiation provokes many unfavorable conditions and destroys the body at the cellular level. Now, all spaceships and the ISS are equipped with shields and coatings that reflect radiation. But still, it doesn't provide 100% protection. In space, the astronaut's immune system changes. There are no conditions under which immunity could improve. It seems that there's nothing wrong with the absence of many bacteria and microbes, but the body's defense is weakening. A person becomes more vulnerable to microbes that can be brought by another astronaut. You also have serious food restrictions. Food in tubes doesn't contain as many useful vitamins as it does in natural products. Without vitamins, the body weakens even more. And sometimes, astronauts have to go on spacewalks, which aren't easy. A spacesuit is a huge and uncomfortable outfit. It constrains your movements and puts pressure on your body. Work in space can last up to several hours. During this time, you sweat a lot. One of the suit's filters may be broken, and all the fluid released by your body can spread throughout the suit and reach your face. Your eyes may water. The drops could interfere with your vision. Thousands of dangers can await an astronaut during a mission in outer space. Imagine that you do some repairs and something goes wrong. The wrench jumps off the bolt and it flies out, for example. You try to catch it and unconsciously push off from the ship. You catch the bolt, but your body is already flying away. You have nothing to hold on to. But fortunately, you have a safety rope. Anyway, it can break off from your spacesuit because you attached it incorrectly. As soon as the rope breaks, your body changes the angle of flight. Now you're not just flying away, your body is spinning at this moment. The Earth and black space flash in your eyes. So you get it. There are definitely risks, but nothing like that happened with Sergei. All astronauts spend many hours training to be ready for any troubles. They gain good physical shape and lose it during the mission. Add to this the psychological factor. Your body weakens, you don't breathe fresh air, you can't see your friends, and you don't have the opportunity to return home. A small layer of wall separates you from the cold vacuum of space. All this causes stress, which also weakens your immunity and harms your nervous system. Fortunately, astronauts also get through serious psychological training. They can maintain self-control in the most stressful situations. But when you're alone in space for more than 6 months and don't know when you'll return, you can get seriously nervous. Fortunately, Sergei didn't panic. He performed his daily duties, trained, and of course, missed home. A month later, he received the same response. "We can't bring you back yet. The country is in a difficult situation." He felt worse every day. His strength was leaving him. He wasn't sure if he'd be able to survive. The most interesting thing is the station had a capsule developed to return to Earth. But Sergei didn't use it because no one would have served the station. Russia sold the station seats to other countries. Also, they hoped to sell Mir. This meant that Sergei had to keep the station working. Sergei's mission lasted twice as long as planned. As a result, he spent 10 months, or 311 days, in space and set a world record. During this time, he flew around the Earth about 5,000 times. Finally, he received the long-awaited message. He's coming home. Germany paid about $24 million for a ticket to the station. They were going to replace the astronaut. Krikalev got into the capsule and flew to Earth. Many people were waiting for his return down there. The cosmonaut landed, and everyone rushed to help him. He looked very thin, sweaty, and exhausted. 4 men helped him out of the capsule. They helped him stay on the ground, gave him a fur coat, and brought a bowl of broth. It seemed that such a flight would leave an imprint on his life forever. But the cosmonaut's mood was excellent. 2 years later, he went into space again and became the first Russian cosmonaut to fly on a NASA shuttle. And 2 years later, he was one of the first to live on the ISS. In 2005, he made his 6th and last flight. He went to the ISS, where he spent about 6 months, after which he returned home on the lander. After this flight, he set a world record for the total duration of stay in space, at 803 days. Only 10 years later, someone managed to break that record, but that's a different story.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact. but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
Houston, we've got good news. A group of select humans is being interviewed to hop on board the first commercial vacation to outer space. The space agency has given you a survey to answer. They want to know what you would pack on this space adventure. Depending on your answers, you just might be one of the chosen ones. Now, how about we take a look at that list together? Pencils. I guess I never would have thought of that, but it makes sense. Legend has it that the US spent millions of dollars trying to design a pen that worked in space. You know, since the lack of gravity is a huge, inescapable factor of life in outer space, pens don't work. The ink won't flow down as it does here on Earth. It turns out that pencils will do the trick. This way you can play word puzzles with the other space tourists, or even make some drawings of your adventure. You'd never forget to pack a toothbrush, of course. According to veteran astronauts, toothbrushes are so simple, yet their technology is enough for space. If you were to squeeze a water bottle inside a spacecraft, the molecules of water would float around in small bubbles. But if you wet your toothbrush, it naturally holds the water in it, keeping it moist to receive your toothpaste. Oh, I was going to say funny socks. Glad that you beat me to it. Here are two things. First, there's not a lot of walking that goes on in space. People don't tend to touch the ground too much up there. And second, space isn't the best place to showcase your fashion style. Yeah! Astronauts tend to use special clothes while they're out there. And it will be no different for you as a space vacationer. So socks will keep your feet warm and fuzzy, but they'll also speak for your fashion interest. Maybe one day you'll wear a smiley face sock, while the other day you'll go for a Grinch-themed one. Of course, socks are pretty helpful on board an aircraft. They'll make you slide through stuff more easily. Next time I go to the convenience store, I'll remember to buy some wet wipes for your space travel. Experienced space travelers do love them. And it wasn't even NASA that invented them, huh? Since water is a no-go inside a spaceship, the best option is wet wipes. Better yet if they're scented. Astronauts even use different kinds of wipes. They buy the disinfecting ones and the ones to use on their bodies. Just make sure you know how to tell the difference between them when you're up there. There's a popular myth that says that NASA invented Velcro. But the truth is, we tend to think that everything that's used in space was invented by NASA for a very intelligent and specific purpose. It wasn't, though. Velcro was invented for mundane reasons back in the 1950s by a Swiss company. They were adopted by space travelers because they work as anti-gravity props. They don't erase gravity, of course. But you can glue Velcros into daily stuff and then hang them on the Velcro attached to the spaceship's walls. It's a very smart system, but best to take your own pair, right? If you're spending a long time in outer space, photographs from back home might come in handy. Choose them well, though. Since the spacecraft isn't all that big, the rest of the people on board will know which pictures you decided to bring along. Best to keep that Harry Styles poster back in your earthly bedroom, right? Just bring real pictures of people that you know and love. Did I hear pizza? A huge part of traveling and exploring new places is being able to taste different flavors of food. In outer space, that's a bit more complicated. But hey, at least you can take some pizza with you. Well, actually, you'd have to have it delivered to you in a cargo ship. This way, ingredients would come fresh and ready to eat. It wouldn't be the first time that people in space tried eating Earthling junk food. Some astronauts have even eaten crepes and hot dogs. Perhaps the best part of this pizza party would be that your food could float. Now, isn't this a super nice way to enjoy some Earth delicacies? As much as I understand your desire to pack a toilet with you on this space trip, that's virtually impossible. I mean, I understand you. Some people are attached to the toilets in their homes, and a space toilet is far from the ideal experience. But NASA has been improving their toilet system, and it's the best it's been over the years. So that will have to do. Here's something I would take as well: a laptop. But what good would it do in outer space, you might ask? Apparently, there is internet all over the International Space Station. So even if you're not spending most of your trip docked at the ISS, you could enjoy some Netflix on the days you spend over there. There is internet all over the ISS, apparently. Crazy, huh? And speaking of leisure, I love that you would take a yo-yo. I'm not sure how efficient it would be in space, since there's no gravity to bounce it back and forth, but it would be nice to see how a yo-yo reacts in a gravity-free environment. Oh, I love jigsaw puzzles. This would definitely be on my list as well. Imagine trying to build a jigsaw puzzle that keeps floating in the air. Maybe you'll have to create a system to avoid the separate pieces floating aimlessly through the spacecraft. But imagine once you finish that turtle puzzle, it will look like it's swimming around the craft. You can't pack a window, but they sure are an important part of life in outer space. Let's keep in mind some of the rules of the trip. Each traveler will have the opportunity to do one spacewalk during their time in space. This is already huge. Consider yourself lucky. Some elite astronauts only get to do one spacewalk during their entire career. That is so because spacewalks are risky and require a lot of training. But you'll get your training once you're up there. The thing is, all other days you'll be stuck inside a floating tin can. So windows will come a long way. They'll help to remind you where you are. They'll give you some perspective of space and Earth. Of course, you should take your camera. How else will you be able to register for this once-in-a-lifetime experience? Just make sure it works inside an aircraft or the ISS and you're good to go. Coffee? Don't worry, you don't need to pack your own. Up until recently, astronauts had to rely solely on instantly brewed cups of coffee when they were in space. But you're lucky that coffee experts have already solved this issue. Nowadays, there's the IS espresso machine. The machine itself is similar in size to an Earthling espresso machine. But to drink it, space travelers have to use a zero-gravity coffee cup together with a straw. If you try drinking it regularly, you wouldn't get hot coffee to hit you directly in your face. Instead, the coffee would be glued to the bottom of your cup. I have to say I really stand this invention. Last, but not least, why not pack your guitar with you? I noticed you were missing a musical instrument. If this was a conventional flight, you might have to pay extra for luggage. But since it's all included, don't be shy and take your guitar. Astronauts such as Chris Hadfield take their musical instruments with them when they're in space. He even became famous for his version of Bowie's Space Oddity, up to the point that Bowie himself told him he lived Chris's version of it. It helps to pass the time, but it's also great for socializing. Can you imagine a pretend bonfire happening in the void of space? I can, and it looks super cool. Well, I think you're set to go. I'll personally call NASA and ask them to pick you as one of the lucky space travelers. See you in outer space, amigo.
Picture this. You're planning your dream holiday, but instead of going to a tropical beach or a bustling city, you're thinking about going to space. Imagine yourself floating, weightless, looking down at Earth from a whole new perspective. The beauty and wonder of our planet become even more evident when you're viewing it from a distance. And now, this dream can come true. Yes, you heard that right. Space tourism. Space tourism is something that has fascinated people for generations. This idea has been around for almost 20 years. We've seen it in movies and read about it in stories. But now, thanks to advancements in technology, it's finally becoming a reality. The first space tourist was a businessman named Dennis Tito. He visited the International Space Station in 2001. Sounds incredible, but here's the catch. Tito's trip cost a mind-boggling $20 million. That's a lot of money, and it made space travel seem like a dream that only the super rich could afford. And it's true that space tourism can be quite expensive. But a lot of time has passed since that day, and now space tourism is becoming more attainable for people who aren't billionaires. Of course, the industry is still in its early stages, but the demand for it is skyrocketing, pun intended. Experts believe that it will continue to grow at an incredible rate of around 40% every year from 2023 to 2030. So, with all this in mind, let's talk about what awaits us in the near future. There are different types of space tourism. First up, we have suborbital spaceflight. It's the trip where you reach an altitude of over 300,000 feet, which is way higher than any airplane can go. In fact, it's so high that you cross a special line called the Kármán line, which marks the boundary of outer space. How cool is that? So it's basically like a quick jump into space and back. So let's talk a bit more about suborbital spaceflight. Imagine you want to go on vacation to Sydney, but you live in London. Normally, it would take you about 22 hours to get there by plane. That's a really long time to sit on a plane. But guess what? Scientists and engineers are working on a new way of traveling that could make the journey from England to Australia super fast and exciting. Suborbital space trips could be used for quick travel between different cities on Earth. Instead of flying in a regular airplane, you would hop on a spacecraft that can go really, really fast. According to a recent study, in the near future, it might be possible to fly from London to Sydney in less than 2 hours. Just imagine how amazing that would be. You would zoom up into space, see the Earth from above, then come back down in no time at all. What an adventure! This study, conducted by the UK's Civil Aviation Authority, was all about understanding how our bodies react to trips outside Earth's atmosphere. To figure this out, the researchers needed some brave volunteers. They recruited 24 healthy people between the ages of 32 and 80. These volunteers were taken to a special training facility called an RAF centrifuge in Cranwell. A centrifuge is a big machine that looks like a giant spinning chair. The volunteers were sat in there to experience a simulation of spaceflight. They were spun around, and their bodies felt the pressure and changes in gravity that happen when you go into space. Almost everyone handled the simulation pretty well and quickly returned to normal. One person even briefly lost consciousness, but it was because of the gravitational forces, and they recovered soon after. Now, this study found some surprising things. Many people think that you have to be really fit and young to handle space flights. But the research showed that older people can actually cope better with all this gravity craziness. So even if we don't develop space tourism in the next decade or two, you'll still have a chance to visit space even when you get old. Right now, there are two big players in the suborbital spaceflight game: Virgin Galactic and Blue Origin. Both of these companies have rocket-powered systems that can take up to 6 passengers on a thrilling ride. Virgin Galactic has already had 4 successful flights, but they recently ran into some financial trouble. On the other hand, Blue Origin has flown 32 passengers on their new Shepard rocket. The catch is pretty obvious. Right now, space tourism is super expensive. Companies can charge a whopping £350,000 per seat for these flights. But don't worry, things are about to change soon. Experts believe that space tourism will grow in the coming decades. It will be kinda similar to what happened to airplanes. Right now, the cost of a quick trip to space is very high. But as time goes on, the prices will go down. Eventually, space tourism will become more affordable and accessible to people all around the world. That means not just our children, but many of us will have a chance to experience the wonders of space. As technology advances, we might even be able to plan rocket-powered holidays in the future. Can you imagine telling your friends that you went on a vacation to space? What a flex! And now, let's talk about orbital spaceflight. This is the real deal, where you get to spend more time in space. Instead of just a few minutes, you can spend anywhere from a few days to over a week up there. And we're not talking about a measly 300,000 feet anymore. We're talking about going over 1.3 million feet high. So whether you're up for a quick jump into space or a longer adventure orbiting our planet, space tourism has something for everyone. Sky is no longer the limit. But space tourism isn't all fun and games. There are some challenges we need to consider too. First off, let's talk about the environment. Launching spacecraft and rockets takes a lot of energy and can create air and noise pollution. This can seriously harm our atmosphere. We don't want to trade a cool space trip for a damaged planet, right? Next, there's the issue of safety. Space travel is still risky, and accidents can happen. Even with safety protocols in place, there's always a chance of something going wrong. And if it does, the consequences could be really, really bad. Yikes! Space debris is another concern. Every time a spacecraft is launched, it leaves behind debris that can stay in orbit for a long time. As more launches happen, the amount of debris keeps growing. This can cause problems for other spacecraft, and even small pieces of debris can cause damage. Space travel also requires a lot of resources like energy, fuel, and materials. Using up these resources too quickly could have long-term consequences for our planet and future generations. We need to make sure we're not depleting everything in our quest for space exploration. Oh, and let's not forget about all the legal stuff. The rules and regulations for space tourism are still evolving, and it's not always clear who should be responsible if something goes wrong. Plus, there are concerns about how space tourism might affect international space laws and treaties. We don't want legal chaos in the final frontier. And finally, to achieve our dream of taking spaceships like planes, we'll need better infrastructure and logistics. We'll need to build more spaceports where spaceships can take off and land. But don't worry, scientists are actively working to solve these problems. Remember, it's not just us who are excited about space tourism, even governments are joining the fun. Many countries are investing in space tourism too. It's a global phenomenon. So even though there's still a lot to develop in this industry, it's pretty obvious that the aviation industry might go through a big revolution. Traveling long distances would become much quicker and more exciting. And judging by the way development is going, the first big breakthrough in this area will be made in North America. So, get ready for a new era of travel. What an exciting time to be alive, right? The universe is calling, and it's time for us to answer. Stay tuned.